Okay, two coils are placed side by side and fixed to their positions when there is no current in coil 1 and current in coil 2, okay, increases at the rate of 10 ampere per second. The induced EMF in coil 1 is 20 millivolt. Find the mutual inductance of this pair of coils. Okay, good. So now, this is about mutual induction or self-induction. Is it one coil or two coil? So this one has two coils. You see that? Two coils. You have coil 1, you have coil 2. Okay, so if the question say it has two coils, yeah, then it is mutual induction. Mutual induction, the mutual inductance is M. Okay, about M. So if only one coil, then it's self-induction. Understand? But sometimes if you have two coils, the question will also ask questions for self-induction, because two coils, two things can happen. It can happen mutual induction for the neighboring coil. It can also happen self-induction for own coil. Yeah, self-induction for own coil. Okay, so two things can happen. If only one coil involved, then it's only self-induction. That is only self-induction. If two coils are involved, then two things may happen. It's either mutual induction or self-induction. Understand? So this you must be very clear. Okay, so this one is mutual induction. Okay, first of all, you have two coils. It's better you list down the information by two columns. Okay, you have coil 1, and also coil 2. Okay, which one has current? We don't know which one is a solenoid. Isn't it? So he said no current. This is important. See, no current in coil 1, but this one current in coil 2. So current in coil 2. See that? So there is current in coil 2. No current in coil 1. This one no. Okay, I can say coil 1 has no current. But coil 2 has current. So what happened is, if we know this, that means what happened is the current changes. There is a current changes at coil 2. Current, I say I2 changes. The current I2 changes. So there will be induced EMF. In coil 1. I say E1 induced. Okay. This coil 2, I can say coil 2 provides the magnetic field and magnetic flux for the coil 2. Which has the current. It provides magnetic field and flux for coil 1, and coil 1 is the one who receive the magnetic flux from coil 2. Okay, coil 1 is the one who receive magnetic flux from coil 2, because only coil 2 has current. Okay, so when the current in coil 2 changes, so there will be changes of magnetic flux in coil 1. So this will causes the induced EMF in coil 1. Understand? So this one, if you look at the formula, is a little bit different. Okay, this one is, you look at the formula, there's a little bit different. So di1, okay, maybe I can list down the formula first. List down the value first under coil 1 and coil 2. So we have no current in coil 1, current in coil 2 changes at the rate of 10 ampere per second. So this is di2 over dt. It's coil 2, so this is di2 over dt. Understand? Di2 over dt, because this di2 over dt happen at coil 2. The changes of current happen at coil 2. Understand? Okay, you see here the word increases. Increases means it's positive. the di increases means the di over dt is positive. Okay, the positive here, it means it means the current, because current increases, then it's positive. Okay, so it's a positive 10 ampere per second. If decreases, if you say current decreases, you must put negative sign. Okay, if just an extra note, if you say current decreases, you should put a negative sign. Don't forget the negative sign. Okay, if if you write as negative 10 ampere per second, if you write as negative 10 ampere per second, that means for every second the current decreased 10 ampere, the current dropped 10 ampere. If you write as positive 10 ampere per second, that means for every second the current increased 10 ampere, increased 10 ampere, increased 10 ampere, increased 10 ampere. For every second, increase 10 ampere. This is mean by positive. If negative 10 ampere per second means for every second the current minus 10 ampere, minus 10 ampere, decrease 10 ampere, decrease 10 ampere, decrease 10 ampere. That is mean by positive negative sign here. So it's very important. If the question here he says decreases, if here he got word decreases, if you say coil 2, the current in coil 2 decreases at the rate, then here you should put negative. Understand? Very important. If you don't put the negative, then you are wrong. Okay, this, if negative means the current decreases. Okay, if here he say decrease, now increase means it's positive lah. Okay, it's positive. All right, so okay. Okay, so now, okay, I got the information ready. Now induced EMF in coil 1. Here it said induced EMF in coil 1 is 20 milliampere. So this one is E1 induced EMF, induced EMF in coil 1. Okay, induced EMF in coil 1 is 20 millivolt. 20 millivolt change to SI unit. Milli is exponent negative 3. Exponent negative 3. So I got this 20 exponent negative 3 volt. Okay, so you see what happened is there is a changes of current in coil 2. Okay, changes of current in coil 2. This coil 2 provide magnetic flux for coil 1, and because there is a changes of current in coil 2, so there will be changes of magnetic flux which it provide for coil 1. If changes of magnetic flux which it provide to coil 1, so as a result, EMF is induced in coil 1. EMF is induced in coil 1. Okay, so this EMF induced in coil 1 is actually a result of changes of current in coil 2. This is mutual induction. This EMF in coil 1 induced is because of changes of current happen in coil 2. Okay, so all right, so now this formula I should change a bit. This in the notes here here is opposite. You see, this one in the notes, this one assume the coil 1 has current. Yeah, maybe I should. Okay, I write first coil 1, coil 2. Okay, this one assume the coil 1 has current. This one, coil 2 has no current. So EMF is induced. EMF is induced in coil 2. Understand? EMF is induced in coil 2. So that's the opposite lah. Okay. For the nodes, the equation is being built up based on the understanding that the coil 1 has current, coil 2 has no current. Okay. EMF is induced in coil 2. But it's opposite from the questions. Now the one has current is coil 2, not coil 1. In the nodes, this one, the coil 1 has current. Coil 1 has current. But in the question is coil 2 has the current. Not the coil 1. Yeah. So it's opposite. Yeah. The coil 2 has the current. EMF is induced in coil 1. But in the equations here, the coil 1 has current. Coil 2 induce the EMF. So it's opposite. You see that? This one is E2 induced. This one is E1 induced. This one is current in coil 1. Coil 1 has current. Coil 1 has current. This one is coil 2 has current. So it's opposite. So what happened is all this EMF is induced in coil 2 because current in coil 1 changes. Yeah. So how to use in our context? We should change it. We should change all these become if it is E2 EMF. Now we are taking that coil 1 induced EMF. Coil 1 induced EMF. Coil 1 induced EMF because there is a changes of current in coil 2. Changes of current in coil 2. So what I have to do is EMF is induced. Okay, I should change. EMF is induced in coil 1. Turn 1, change of flux in coil 1. EMF is induced in coil 1. And then because there is a changes of current in coil 2, changes of current in coil 2, so this is di2 over dt. Understand? Change a bit. And then below here also I change. This one is current. Which one has current? Coil 2. Coil 2 has a current. Coil 2 has a current. Okay, coil 2 has the current. Coil 2 has the current. Okay, coil 2 has the current. And then coil 1 receive the magnetic flux from coil 2. Yeah. Coil 1 receive the magnetic flux from coil 2. Just the 1 change to 2, 2 change to 1. That's it. 2 change to 1, 1 change to 2. Yeah, everything like this. Yeah, opposite. And then what? This one mu naught n1 n2 still same. But this one is A2 already lah. A2 because area and length take the one with take the coil which has the current. Okay, the one has the current is coil 2. So this one is A2. This one also length for 2. Understand? Okay. So hold on a second. I just want to write this below here. Let's put as a notes. Yeah. Okay. So okay. All right. Put it over here. Yeah. Okay. Okay. So now this one is our context. This one is okay. This one is based on okay, we have coil 1, coil 2. Okay. This one coil 1 has no current. Coil 2 has coil 2 has current. So EMF is induced. EMF is induced in coil 1. EMF is induced in coil 1. Okay, that's the difference. Yeah. and the change of there's a change of current in coil 2. Wait, this is di2 over dt. Okay. And initially this one is di1 over dt. Yeah. Okay. So can you see the difference? Okay. This is our questions here, and this is the original notes. Yeah, original notes. Last time is coil 1 has the current. There is a change of current in coil 1. So induced EMF in coil 2. Now is there's a change of current in coil 2, induced EMF in coil 1. Induced EMF in coil 1. So that's a opposite. So the equation also all become opposite. 2 become 1, and then 1 become 2. This one is 1 1 1 2, 1 1 1 2. This one is 2 2 2 1. 2 2 2 1. Okay. So I hope you are clear for this one. I think I should. Okay, I think that's enough. Okay, I hope you understand. Okay, I hope you understand for this one. Okay, that's the one lah. Yeah, I hope you can see the notes. All right. So okay. So let's do these questions. Yeah, let's do these questions. So how to find the mutual induction? How to find the mutual induction for this pair of coil M? Yeah, mutual induction. Question A. Yeah. So what formula going to use? We're going to use this one. Okay. So we're going to use this one, E1 equal to negative M di2 over dt. And we can find the M. Okay. Let's use that formula. E1 equal to negative M di2 over dt. Di2 over dt. So okay, so is mutual induction. Actually, this one is you have a negative sign. Yeah, actually this one you should have the E1 should have a negative sign because it's back EMF. Yeah, because it's back EMF. So this E1 is actually negative 20. If you don't put the negative sign, for EMF, then the mutual induction will have negative sign, which is weird. Yeah. So back EMF should actually always have a negative sign. Okay. So should put a negative sign there. Okay, should put a negative sign there. So so this one is you should have a negative sign for the EMF one. So which is 20 milli is a negative 3 volt. Okay, negative 20 exponent negative 3 volt, and then negative M di2 over dt is positive 10 ampere per second. 10 ampere per second. Okay, so I can find my mutual inductance. So how what's the value? So it's 2 exponent negative 3 Henry. 2 exponent negative 3 Henry. That's the answer. Okay, is that correct? 2 exponent negative 3 Henry. Yes, that's correct. Okay, exponent negative 3 Henry. That's correct. Okay, so that's the answer. That's question A. Okay, now look at this following question. If there is no current in coil 2 and coil 1 has the current 3.6 ampere, what will be the flux linkage in coil 2B? Oh, this one is for flux linkage, the word linkage. So that means yes, it's the capital phi. Capital phi has n turns, not just one turn, for all the turns. Okay, for all the turns. So it's flux linkage. You want to find flux linkage. Yeah, has n turns. The capital phi. Yeah, capital phi. Okay, now he say it's no current already. No current in coil 2. So now is no current. Last time is what? Last time is got current in coil 2. Got current in coil 2. Current coil 2. Coil 2 has current. But now the B is no current in coil 2. Coil 1 has the current. So it's interchange. Interchange. Okay, let's write down. B. Now between coil 1 and coil 2. Okay. Okay, B1, coil 1 and coil 2. Okay, which one has the current? I say coil 2 has no current. Coil 2 has no current. So this one has no current. But coil 1 has current. Okay. Coil 1. Now coil 1 has current. Coil 2 has no current. So what I can say is there is a now current. I can say the one has current. That means there is the I1 can changes. So this induced EMF in coil 2 lah. Mutual induction. Okay. The coil 1 provide the magnetic field and flux for coil 2. He provide. Last time is coil 2 has current, provide magnetic flux for coil 1. Now is coil 1 has current, provide magnetic flux for coil 2. And EMF induced in coil 2. Okay, last time EMF is induced in coil 1. Now EMF is induced in coil 2. Is interchange. Okay, so information given is he say okay, coil 1 has current 3.6 ampere. So this I1, this I1 3.6 ampere. This I1. So put that as I1 3.6 ampere. 3.6 ampere. So I want to find magnetic flux linkage in coil 2. Okay, what's the flux linkage in coil 2? So I want to find what's the flux linkage. That means capital Phi 2 flux linkage in coil 2. So how to do this flux linkage in coil 2? I think this one you use the what? This is also mutual induction. This one is you use this one. You see this bottom one. Now coil 1 has the current, right? Coil 1 has the current. Coil 2 induced EMF. Okay. So to find magnetic flux linkage for coil 2, you use this one. I use this one. Okay. So MI1 equal to N2 Phi 2. Okay, so I use this one. Okay, so I use this formula. Capital Phi is equal to I can say N2 Phi 2 is equal to MI1. MI1. So this thing, this N phi is actually equal to the capital Phi. This actually is equal to capital Phi. Okay. So capital Phi magnetic flux linkage in coil 2 equal to MI1. This mutual induction can use back this value. Because it's the same. Yeah. Although you change the one who has the current, the mutual induction will remain the same value. Okay. So put in the mutual induction just now. We got 2 exponent negative 3, and then I1 is 3.6 ampere. Okay, so what's the answer? Okay, so what's the answer? 2 exponent negative 3 multiply 3.6, so it's a 7.2 exponent negative 3 verbal. That's the answer. Okay, am I correct? That's correct. 7.2 7.2 exponent -3 verbal. And not watt. This one actually should be wrong unit. This one is wrong unit. This one is actually verbal, not watt. Watt is actually for power. This is for power. What is for power? W is for power. W is for power. Verbal is for flux. Verbal is for flux. Okay. So that's the answer. Yeah, I'm correct. 7.2 exponent -3 verbal. Okay. All right. So that's the answer. Okay. All right. So I hope you understand. This one is for this case, and this one is for this case lah. Yeah. This one is for coil 2 has a current. Coil 2 has a current. This one is for coil 1 has a current. Coil 1 has a current. So it's different lah. So you interchange lah. Okay. This one is Mi2 N1 Phi 1. This one is Mi1 N2 Phi 2. So it's interchange. Okay. This is a linkage. This one is flux. Capital Phi is called flux linkage. Okay. Small phi is called flux. Okay. The question asks for linkage. So you should capital Phi. Okay, that's all for this question. Okay, thank you. Bye bye.